color, or was the HTTP already added, or was that already present in the log file, or did you just add the tag of the HTTP?
I add the tag to HTTP. So I do need to kind of record this additional information, right? For example, in your
that didn't even have the sendmail or the HTTPD, it didn't have any of that.
No, they do. Before you can use the system. So during the system initialization stage, we pre-color or we pre-taint, these different software, like SendMail, HTTPD, DNS, things like that, right? So this is great because you can safely ignore those blue entries without affecting the accuracy of your investigation result. Yeah.
How would it be different than actually maybe taking the process number or maybe the actual name of the process?
That's a great question. In fact, I have an answer. I have an answer to this question in my technical report. So basically, in short, we cannot use the process ID as the partitioning index because the process ID does not get inherited and propagated throughout the process creation and the and other process operations. If you look at, for example, the child process created by a parent process, does the child process inherit the process ID? It does not, right? It is assigned a completely independent process ID. So if you use the process ID, you lose the provenance, you lose the lineage of its origin. Yeah.
So this is a separate fork that you're creating, or how's it actually implemented?
You have to modify the operating system kernel. So for every system call, you need to add this tainting operation. Okay. That's why we call it the operating system level tainting. So in fact, this also show you a part of the investigation or the reconstructed episode of SLAPper1 infection, right? And you can see like the ovals are the processes, right, with the process numbers, and also you will see that, for example, now you see like there are two different IDs, right, 2568 and 2587. So if you only use the process ID, to do the partition, you will assume that 2568 and 2587 are not related, right? However, they are in this case because they are tainted with the same red color, and this is only part of the SLAPper1 intrusion steps. So a more complete description of the complete description of a SLAPper1 intrusion is shown in this figure. So it involves multiple things, including the spawning of a shell, and also creation of new files, and also the attack, and also the launching of the next the next round of infection and propagation. So these are the kind of the system level features, right, of process coloring. So process coloring is based on a very solid theoretical, a solid theory. It's based on more specifically information flow theory. So information flow is a well-established theory that captures the interaction and influence between objects and subjects. So this work is actually I consider it as the instantiation of the abstract information flow theory in the context of operating system and also operating system level objects and subjects. So here, each subject, every process is a subject. The subject is active, right? And each, like the file, directories, or sockets, shared memory, and these things are considered objects. So these are shared resources manipulated by the subjects, namely processes. So when the process perform an operation on an object, or a process perform an operation on another process, there are information flows that go between these subjects and objects. So the task is to capture them and preserve them in the log. So this is something that was not done in the traditional log-based tools. And also, I would like to point out that process label is the model defined in Florian's PhD thesis, and our work is an instantiation of the process labeling framework in the context of malware investigation. We also looking at the experimental platform, we have also been developing a virtualization-based platform for integrated malware capture, investigation, and defense. So for the detection and capture of malware, we have built a architecture called a honey farm. So a honey farm is nothing but a bunch of virtual machines waiting to be attacked by real-world malicious software, right? And then once you capture, for example, a specific incident, you are able to get a live copy of the bad thing, named like the viruses or the worms or other malware, and then you can do some further investigation. And then in the background, you want to redirect, you want to unleash, the malware that you capture. Then you kind of unleash it and you let it run and you observe what kind of bad things it does, right? And usually this is very dangerous and high risk because you don't want any negative impact, to be leaked to the real world. So that's why we have some, advanced techniques based on virtualization technology that achieve the strict confinement of all these negative impacts. So I call this the testing ground. I call these the malware testing ground, right? The testing ground has to be confined, and in the meantime, the testing ground has to have a high fidelity, because now the malwares are getting more and more smart. If they realize that they're running in a testing ground, they will stop doing the bad thing. So you need to kind of you need to come up with some advanced technique, to make them believe that they are running in a real and a malicious system. So once we have these, like the honey farm front end for the capture of malware and the back end to replay the malware, we come up with we come up with a bunch of defense and investigation mechanisms. So these are actually, this is just the kind of for advertising purpose. So we have done some other work, including the characterization of the behavior of malware. This work was reported in the Warren workshop this year. And also we tracked the contamination done by the malware. This is actually described in this talk today. And also we have some defense mechanism that will randomize the system runtime environment so that the malware cannot perform the bad things in the first place. So I'm going to focus only on the contamination tracking, based on process coloring. And all these are enabled by virtualization. And in a moment, I will show you why virtualization technology is important. So you realize that the key to the log-based investigation tool is the collection of log. Because once you have to, in the first place, you have to have trustworthy logs. If you don't trust your log entry, then it's kind of like garbage in, garbage out, right? You have to make sure that your log entries are trustworthy. However, this is very difficult to achieve if you don't do something extra. So just take a look at the regular way of collecting logs. Usually the logging module, is supported by the operating system, and it is running in the same system as the system that you are monitoring. So this creates a problem because, philosophically, if you want to monitor something, you're not supposed to be part of that something, right? You have to be somewhere outside. However, most of the current monitoring logging mechanism resides within the system that it is monitoring. So that creates a problem. Because once the system gets compromised, you can no longer trust the log collection mechanism, and correspondingly, you cannot trust the log entries. And then all bets are off, right? Garbage in, garbage out. And let me show, what time is it?
It's 7.
7. I have, okay.
About 15 minutes.
All right, so let me just quickly show you this figure shows the current implementation of a system called logging mechanism, how it is implemented in most of the current software system. So I want to just quickly show you how system call is made, right? You have the system call dispatcher in the operating system. Depending on the ID of the system call, it gets dispatched to different code in the operating system kernel, and then once the results are generated, it will get back to the dispatcher and get back to the user space. This is how system call is performed. And in order to record the system call and its corresponding action, this is the standard, quote-unquote, state-of-the-art implementation. You just insert that logging mechanism between the dispatcher and the actual operation, the actual execution of the system call, right? So once you have that, you can, intercept the call, and then the system call will just, the system call path, the execution path, will have to go through this logging mechanism because everything has to be logged. The problem is that this can easily be bypassed. And there have been reports that show that it can be, such kind of system call interception mechanism can easily be either bypassed or fooled. and this can be done even